We're now going to turn our attention to yet another type of transforming operator that's defined in the observable class. This is a very important discussion because you'll need to know how to do this for your assignment, number 4A. And remember, transforming operators transform values and or types that an observable emits, like a transformer toy. And we're going to look at two of them here, flatMap and flatMapCompletable. So flatMap is one of the most important operators in RxJava. It's used all the time. And it's used to transform the elements that are emitted by this observable asynchronously, at least most commonly used asynchronously. And the items that are emitted are based on applying a function to each item emitted by the observable. So as the items come in, the mapper function is applied, and then the results come out to the next part of the stream, downstream. The function that's passed as a parameter returns something called an observable source. And you can see that that's what this is here. And the reserved observable sources are all merged together, and the results of this merger are flattened and emitted. And that's where flatMap comes from. And this should sound somewhat familiar because we have a flatMap operation in Java streams as well. And we'll compare and contrast them here shortly. Notice that the way that observable sources work, it's often done asynchronously. And so it's entirely possible for the values that are emitted to be interleaved. So you can kind of see here that we've got some red value coming in and a green value and a blue value. And we could have the red values followed by a green value, followed by a blue value, followed by another green value, followed by a blue value. They aren't put together in any particular order. And that's by design. Another thing to note is that the number of output elements that come as a result of flatMap being applied can very well differ from the number of input elements, which is different from map. Map always has a one-to-one correspondence, whereas flatMap has a one-to-many, or you could have either many to fewer or fewer to many, or you could actually have the same number come out. It really all depends on what you're doing. But notice that you don't necessarily get the same number out as you had come in. And also notice as well that you can transform values or the types of values. So you can either change the values by multiplying them or adding them or dividing them or doing some computation to them. And you can also change their type, going from integer to string, or from string to search results, or whatever you need to do. You can transform the values and or the types. The flatMap operator is used for a bunch of things. It's very commonly used in RxJava in conjunction with concurrent processing. And we're going to talk about this in the next part of the lesson in more detail. It's something that's called the flatMap concurrency idiom. And you'll get a chance to see how that all works. Here's a kind of an overview of this, just to kind of give you a preview of coming attractions. But basically what's going to happen here is this flatMap operation is going to end up taking a stream of big fractions and then multiplying all those big fractions by some constant in parallel in a thread pool that's defined by the RxJava framework. And so we'll talk about that in more detail when we get to the next section. That's a very, very common use for flatMap, and it's also why the operations that run are often asynchronous, because they're actually running concurrently, and that's one other reason why the results can interleave. Not surprisingly, because this is such a foundational capability in RxJava and in RxJava, it's also something that's provided in Project Reactor. So Project Reactor has this thing called a flux that has the same essential semantics that RxJava's flatMap has. So Flux flatMap, RxJava flatMap work the same way. And they're both somewhat similar, at least at a high level, to the Java Streams flatMap method, which we've looked at before. But there's one very important difference. Stream flatMap does not support parallelism. It only runs sequentially for reasons we've talked about earlier in the course. In contrast, the flatMap operators that come with RxJava and Project Reactor are largely designed to be run in parallel. So that's a very important difference, and I think an improvement as well. flatMap doesn't ensure the order of the items in the resulting stream. Just always keep that in the back of your mind. If you want to get ordering, then you want to use concatmap, which will ensure that the output goes in the same order as the input, even if there's additional values that are generated as part of all this. So let's take a look at another operator that's kind of a variant of flatMap, which is kind of a wacky variant of flatMap, but it turns out to be very helpful, called flatMapCompletable. And flatMapCompletable maps an observable, which you're observing using this mapper function, into a completable. In other words, it maps each element in the current observable into completable source objects, and then it subscribes to them, and it waits for the completion of all the operations, and then it returns something that's called a completable. So you get back a single completable instance. Now you might ask, what on earth would that be good for? And that would be a good question. So the completable that's returned will wait, I'm using the word wait here loosely because it's not really blocking, it's just going to be notified for the upstream observable's terminal event, namely the onComplete method to be called, at which point the completable will be complete. And we use flatMapCompletable in our implementation of the RxJava version of the async task barrier. So if you recall, we have this async task barrier. I always show you that whenever we look at the test programs. And it's basically barrier synchronization. It lets a bunch of asynchronous operations run in the background, or asynchronous tasks. And then as they complete, it keeps track of them as they complete. And when they're all done, then it returns. And if you take a look at the implementation of async task barrier, which we will do at some point when we get a little further along, you can see what it does is it takes all the list of tasks to run, it runs them all, and then it uses flatMapCompletable to wait for them all to be finished, and it gets a completable back, which doesn't yield a value. It just says everything's done, and then at that point, we can go ahead and wrap things up. So we'll take a look at that when we look at the implementation later. Oddly enough, Project Reactor has no operator like flatMapCompletable. However, if you really put your mind to it, you can use Project Reactor's flux then and mono then operators to give you a simple, similar capability that can be used in conjunction with flatMap. So it's not quite the same as having a flatMapCompletable, but there is no completable type in Project Reactor, but you can get something very similar. And we use that actually in our Project Reactor implementation of the async task barrier. And then finally, the Java Completable Futures framework has an all-of method, which we've looked at before, and you've got a chance to use that as the basis of some of the collectors you've worked with, particularly for assignment 3, that can be combined together with the Java Streams collector framework to give a similar kind of behavior as we get with flatMapCompletable. Again, not identical, but along the same sort of lines. And you can take a look at this link at the bottom of the slide if you want to refresh your memory about how we can use collectors in conjunction with the completable future all-of method. So that's the end of our overview of key transforming operators in the observable class part 2. We're going to look at part 3 in a second and dive in more detail into the way in which the concurrency idiom of flatMap works in RxJava.